until everyone's taken it. They weren't as good as we wanted them to be, so we are going to give everyone the opportunity to buy back some points. So that information will be given to you by the end of the day today. Basically what it is that, say you missed problem 3. You will have the opportunity to correct problem 3, and then you will complete 3 similar problems. Say that problem used the perfect square trinomial method. You would then need to complete 3 more problems that use the perfect square trinomial method. So we will send all that information out later today so that you can work on that. Any questions about that process? You'll get an email about it.
Please make sure you are checking your emails. So once you do get an email, you can then check your quiz grade. On your quiz, just like you submitted to me, I submit it back to you. So there's an edited version from me that you should be looking at and kind of reviewing the problems that you missed on every test or quiz. I do leave feedback just like I would on any other paper copy quiz or test as well.
Okay. So moving forward, we are starting section 4.5, which is about solving quadratics by finding the square roots. In chapter 4, we're going to learn how to solve quadratics 4 different ways. The first one's factoring, which we just did. Today we're going to work on square roots. Then there's 2 more, one using the quadratic formula, and then completing the square. So we're going to talk about all of those before Thanksgiving break.
And then you will have a test the day before Thanksgiving. And if you thought yesterday's quiz was difficult and you had a hard time completing it in 35 minutes, then you really need to start buckling down. Because the test prior to Thanksgiving, if yesterday's quiz was difficult, it's a longer test and it covers 5 methods of solving equations. The quiz yesterday was 1 method, factor. So put that in the back of your mind. Start timing yourself when you're doing review worksheets, when you're completing homework. Make it a test for yourself. Can you complete a test in 40 minutes? Because some of you can't, and that needs to change. Because there is no extra time with tests. And that's standard honors for this building. Like, not just a Mrs. Kane thing. That's a math department thing.
We'll also have a short factoring quiz at the beginning of class, one of the days next week. So it's not, factoring doesn't go away. So practicing it is only going to benefit you. All right, so let's take out your note packets or get it up on your iPad. We are going to start on page 13 for today. So like I said, we're moving into the square roots. We're going to do that today, solving quadratics by finding square roots. We'll go over some products or properties of square roots, and your homework is a practice worksheet. It's right down here. This will be on Google Classroom for you to complete. All right. So we're at the top of page 13. Does it need to, it's like lighting up at the bottom. Okay.
Again, 2006.
Mm-hmm. Okay. So we're going to look at simplifying these square roots. What's the square root of 100? Gina? Yep. Is 200 a perfect square? Right, it's not. So How can we break up the square root of 200? What two things multiply together to be 200 where one of them may be a perfect square? Jaden? Yeah, so we can break this up into 100 and 2. Two radicals being multiplied together is the same as what we just did. So this is, we can take that 200 inside that radical and split it up and put them both under square roots. Now we just found out that the square root of 100 is 10. So what could we simplify that to? Cody?
You can simplify 100 squared.
Yeah. And we can't break down that root 2. That doesn't have a square root. So this would be 10 root 2. Now go ahead and try root 75. How can we break the square root of 75 down? Alyssa?
I did 25 and 3.
Yeah. Then what can we do?
Get 5.
Yep. We can't do anything with that root 3. So root 75 simplifies to 5 root 3. Good. All right, so now let's go over some definitions. We know that the square root of a number, we know what this is, we just went over it. So it's the square root of a number x is a number y where y squared equals x. The radical is the whole square root. So say we have root s. S is a number. The radical is this whole thing. The whole thing, we call that a radical. That s inside of it is the radicand. So then this s is that number inside. So now let's look at some properties. So the product property, if we have root a times b, we can split that up into taking a times b under square roots. You can break that number up into its factors. So just like we did above, root 18, what two factors can we break that into, 18? Gabby Sol.
2 and 9.
Yep. So then what's root 9? 3. Yep. So then this could be 3 root 2. And then when we have a fraction inside of the square root, we can just take that square root and break it into its own square roots on the top of and bottom. You can break that fraction up, set the square root is just on the numerator and then just in the denominator. So if we have root of 2 over 25, we know by this quotient property, we can make that root 2 over root 25 And how can we simplify this? Jaden? Yeah, exactly. And this answer is fine because we don't have a square root in that denominator. Good. All right, so go ahead and try these practice problems. I'll do the first one with you. So we have root 24. By that product property, how can we split this up? Gabby Soul? I'm sorry, my brain's not working. You're fine. Think about the factors of 24. What two things multiply to 24?
12 and 2, 7, 3, 8.
There's one more that I'm looking for.
6 and 4.
Yeah, 6 and 4. Because we want one of them to be a perfect square. We need one of them to be a perfect square to break it down. So if we have root 6 and root 4,
Root 4 breaks down into 2.
say it again.
4 breaks down into 2.
Yep, exactly. So then I'll just flip it around because those are being multiplied. We know that that 4 goes into 2. Or 2 is the square root of 4. So that's 2 root 6 because that's 6 we can't break down anymore. So now let's look at B. Can we take the square root of 5? Right, we can't. Can we take the square root of 18? Can it break up into anything? Julia, go ahead.
Would break up into 9 and 2.
Yeah, this 18 could break up into 9 and 2. So now we have, what can simplify more from the root 2 and root 9?
9 can become 3.
Yep. So that's 3. So now we have this root 5 being multiplied to 3 and root 2. Now we always bring that number to the front. So let's bring that 3 to the front. And now we still have this root 2 and root 5. Can we break either of those down? Yeah, we can. I agree. So then we're going to multiply them back together. So look back at the product property rule, how we can break it down into two different ones. Well, we can do the reverse. We can bring them back together. If we can't get that, either of them are perfect squares, let's bring them back together. So then what would this be? 3 root what? Ella? Yeah, exactly. We're going to take that 5 and 2 and just bring it under the same radical. And they're being multiplied. So that's 3 root 10. Now you don't need to show that step. I'm just showing that so that you understand what we're doing. So we're trying to break these numbers down into what perfect squares fall in them. Part C. Gabby Snyder, how can we break this root over 9 over 64? Yeah, so we are going to split that radical into the numerator and the denominator. We know that root 9 is 3, you said, and root over 64 is 8. And that's it. That's 3 root 8, or 3 over 8. So now looking at D. We have root 5 and root 10. Can we take the square root of either of them? Right, I agree. So what can we do with this? Ella? Yeah, let's multiply them back together. So this would be root what? And then now what should we do?
Square root of 25, square root of 2.
Exactly. Which then equals? Good. So when they're breaking down into these radicals that don't have a perfect square, we want to bring them back together because then we saw we could break it up into 25 and 2. Questions? All right. So rationalizing the denominator. We do not like having square roots in the denominator. It can't happen. So rationalizing the denominator means that we're eliminating the radical from the denominator. And we'll look at an example right below of what that means. So how can we break this root 5 over 2? How can we break that up? What's the quotient property tell us? Lacey?
You do square root of 5 over square root of 2.
Yeah. So we have that radical in the denominator, which cannot happen. So to rationalize the denominator, to get rid of that radical, we are going to multiply the top and bottom by what is in the denominator here. So we are going to multiply it by root 2 over root 2. We need to get rid of that root 2, so we're going to multiply by itself. Because when we do that, when we get root 5 times root 2, what does that equal in the numerator? Gabby Snyder? Yep. And what happens when we do root 2 times root 2? Say a little louder. So what did you do here? You multiplied those two, right? Oh, what did you say? Did you say root 2? Yes, sorry, I thought you said root 2. Good. So that's root 4. And what's the square root of 4? 2. Yeah. When you have two radicals being multiplied together with the same thing inside, the same number inside, it's just that number. Square root x times square root x is just x. And that's what happened here. So that's how we rationalize the denominator here. Go ahead and try part B. Cody, using the quotient property, how did we break that radical up?
8 square root over.
Good. So then how are we going to rationalize this denominator?
Multiply the entire.
Yes, we're multiplying both the top and bottom by that root 3. And then what did you get?
I got 24 over root 5.
Can we keep going?
24 root over 3.
Awesome.
And then you can split 24 root into root 4 and root 6.
Good. So this root 24 can break up into root 4 and root 6. So then we have root 4 times root 6 over 3.
And then you can get 2 root 6 over 3.
Awesome. So in part A, root 10 couldn't break up. We couldn't break root 10 into any other things that we could find the square root of. But this root 24, we could. Once we multiplied it by that denominator, we could break that up. Questions on how we did that there?
Do you remember doing that last year in geometry?
Okay. Cool.
Should have worked with radicals a lot in geometry, all the triangles, the Pythagorean theorem,
Oh yeah. All that
the
fun.
ratios of SOHCAHTOA. Jaden, is that bringing back memories?
All right, so now we're going to take all those things that we know about radicals, and now we're going to solve quadratics using square roots. So part A, we have 1/2 of y minus 6 squared equaling 8. So our variable is in this parentheses. What should we do to try and solve for that y? We have that 1/4 in the front. Lacey, what do you think we should do?
Multiply by 1/4?
Yeah, so instead of multiplying by 1/4, you multiply by what to get rid of that 1/4?
4.
Yeah, we're going to multiply both sides by 4 to get rid of that 1/4. Good. 4 times 1/4 is 1. So now we have y minus 6 squared equaling, what's 8 times 4?
32.
Yeah. So now we have this quantity squared equaling 32. We need to get that squared away. How do we get rid of a square? Jaden? Exactly. We're going to take the square root of both sides, because whatever you do to one side, you do to the other. So now on the left, we are left with our y minus 6. What's inside? That whole quantity was being squared. We took the square root. We're left with what's inside that y minus 6. Equaling root 32. Can we break that root 32 up into anything? Ella?
62.
Mm-hmm. Awesome. So then what does that become?
4 square root 2.
Perfect. 4 root 2. And now what do we have to do to solve for y here? Oh wait, before I move on, we have this variable here. When we are taking the square root when a variable is involved, it is not just root 32. We have a plus or minus. That 2, when we have, this is just like, say we're making x, oh my gosh, y minus 6 equaling x. We have something being squared. That squared means we have 2 answers. So that when we take the square root, we have a plus or minus. It gives us a plus or minus. It gives us those 2 different answers.
So think about the number 9. What times what makes 9? What times what makes 9? 3 times 3. But what else makes 9 besides 3 times 3? Negative 3 times negative 3. So that's why the plus or minus is there. So I have a positive 2 numbers multiplying to be my value, or I could have the same negative 2 numbers multiplying to be my value.
Jaden.
So is there always going to be like the plus or minus of both? Or always?
Yep, that's how we write it.
Oh.
Plus or minus. Yep, they'll just be right on top of one another. Yeah. So now this answer is plus or minus. So now what do we have to do last to solve for y? Julia?
Add 6.
Mm-hmm. So now we added that 6 over, and we are still having that plus or minus 4 root 2. This shows us our 2 different answers. This means that our one answer is that 6 plus 4 root 2, and the other one is that y equals 6 minus 4 root 2. And we always write that real number first. The radical comes second. Good. So now let's do another example. Part B, we have negative 1/5 times x minus 4 squared equals negative 5. Cody, what should we do first?
We get rid of the negative 1 for 5 by multiplying everything by negative 5.
Perfect.
So on the right side, that gives you 25. And then you just have x minus 4 in parentheses squared.
Good. And then Alyssa, what are we going to do next to solve for that x? We have
I'm
the
going to take the root of each side.
awesome. We'll take that square root. And when we take the square root, we are just left with that x minus 4. And what are we going to get on the right-hand side? Ella? What else are we going to need?
Plus or minus.
Yep, plus or minus. So whether we're able to break that fraction or break the radical down, if we're just left with root 44, whatever's in front of it, we have to put plus or minus when we're taking the square roots, when there's that variable that we're solving for. So now, what should we do to solve for x? Cody?
You add 4 to the right side, and then x equals plus or minus 9.
Good. So now we can break this up into those 2 different answers. So what are the 2 different answers here? Lacey?
X equals 4 plus 5.
Mm-hmm.
X equals 4 minus 5.
Perfect. So if x equals 9 or negative 1. When you have that squared, you better be getting 2 different answers. Ella?
For part A, do you have to get like a single number for y? Or is that the final answer?
So could we break that root 2 down into anything?
Like on part B, it's like x equals 9 and x equals negative 1.
Right.
But would we have like y equals a single number?
So these are our final answers here. This is in its most simplified form. We can't combine 6 and 4 root 2. We can't combine a real number and then a number with a radical. So this is,
Sorry. Numbers work like variables. They have to be like numbers in order to add them together. So I can't add an x and a y because the variables aren't the same. So I can't add the 6 with a number that's attached with a root the numbers aren't the same. I know it looks weird having it like that.
Yeah.
It looks like messier than what we started with, really.
Mm-hmm.
But that is the way that some of our answers are gonna be when they're not gonna be exact answers. If I put that in a calculator, I'd get crazy decimal. We're not working on those crazy decimals right now.
So that would be our final answer. So now go ahead and try part C and D.
So when you're doing your homework, don't be alarmed that you feel like your answers are looking weird. They might look like that, because that is an exact answer versus a decimal answer.
Alyssa, what's the first step you took for part C?
I divided each side by 3.
Good. So we are left with
X plus 2 squared equals square root of 9.
square root.
Or it would be
Yes.
plus root.
And now what are we gonna do?
You can take the square root of each.
Perfect. So we are left with just that x plus 2, it's inside. And what are we gonna get on the right?
That's a minus 3.
Perfect. What do we have to do to get x alone?
Subtract 2.
Perfect. So you have -2 plus or minus 3. We can split that up into our two different answers. What are they gonna be?
X equals -2 plus 3 and x equals -2 minus 3.
Awesome. So we get x equals 1 or x equals -5. I like these answers because they're those whole answers. Those are nice. Nella, what do you do for D? Good. Then what are we gonna do? Now what should we do? Yeah, so we're breaking that up into the root 40 over root 3, and we know that root 40 is root 4 times root 10. 4 times 10 is 40. So Ella said that this is 2 root 10 over root 3. Now what do we do? And what are we forgetting? Yep. Now, are we done here? Jada.
Don't you have to rationalize the 3?
Yep. So how are we going to do that?
You're gonna multiply 2 root 10 by square root of 3.
Yeah, we gotta rationalize that denominator. We can't have those fractions in the denominator. Now this 2 is just being left alone. We have plus or minus. What did you get, Jaden? You're okay.
Then you get 2 root 30 divided by the fraction and then 3.
Yep. Perfect. Now are we done? Yes, we are done. We can't break that root 30 up into anything. And we know we have those 2 different answers. Now we can leave our answer written as this. We don't need to break it down. But it's just, I wrote it the other way so that we understand how this is being broken down in those 2 different answers. But this is fine to write your final answer as long as you have that plus or minus. Now this one's an ugly answer. Okay.
So you can see, like, if it's not a perfect square, you can't take the square root of the number. You get an ugly answer. You can take the square root of the number. That's kind of a nice answer.
Questions? Okay, so now we're going to look at an application problem. So example 4 says modeling a dropped object with a quadratic function. So we have a water balloon. A water balloon is dropped from a window 59 feet above the sidewalk. How long does it take for the water balloon to hit the sidewalk? So for an object dropped, this is the quadratic that represents that. It's h equals negative 16t squared plus h with a little subscript of O there. Now this HO, subscript O, this is the original height of the object. So this is the equation that represents a dropped object. That t is time, and this h is the height. This is the ending height. And t is time. So this is the quadratic that represents an object dropped. So now applying that equation, our water balloon was dropped from 59 feet above the sidewalk. How long does it take for the water bottle to hit the sidewalk? So what's the height if it's hitting the sidewalk? Yeah, 0. Equals, we have negative 16. They're asking us to find the time. That's what we're solving for, t time. And what's the original height? Julia. Yeah, that's 59. Good. So now we're going to add this 16t squared to the other side so that we have 16t squared equals 59. So that we're solving for t. Now what are we going to have to do to solve for t? Gabby Snyder. Yeah. So we have t squared over 59 over 16. Now what? Go ahead. Yeah. We get T equals, can we simplify that, root 59? Any perfect squares? Right, yeah, no. So we have root 59 over what? Yeah. And we have our plus or minus. So now we're not going to say it took root 59 over 4 seconds to hit the ground. Plug that into your calculator, see what you get.
The only time you can have a decimal answer is if it's an application problem. It makes no sense to say it's the square root of 59 per second.
That tells me nothing. I
In
don't know.
application problems, you can have decimal answers. 2 decimal places would be a typical value we round to.
Whenever you get the answer, just shout it out. Whoever gets it. Jaden?
Is it 1.927? No.
That is not. Did anyone get a different answer?
I got 3.84.
Yes. Yes. Probably just had a mistake in the way you typed it in your calculator.
I did square root and then I was like hit enter and then I divided by 4. Or
So it looks like you probably had this in your calculator, root 59 over 4. You need to make sure you get that 4 out of the square root.
yeah, I figured out the square root first and then I hit divide by 4. I don't know what
My
happened.
4 was in the square root.
Oh, so then we have the wrong answer.
Yeah.
What Ella, did you get the 1 point?
Out of the square root, I got the 1.9.
So then I did the same thing you did, Gabby. So 1.92.
92.
Thank you. And this is in seconds. And we have this plus or minus. Can it take us negative 1.29 seconds? We have negative time? No. So our answer is the positive answer. Sorry, I went to the very end. Your worksheet is practicing what we did in class. That bottom blurb is just saying how you reject the negative solution when you have an application problem.
You're on tomorrow.
Yeah. Have a great day. See ya.